What if the thing that proves reality is real is the very thing that proves it's not? A single number hidden in the cosmic microwave background that no physical law can explain. A number that looks less like a natural accident and more like a rounding error in someone else's code. But before we get there, we have to start somewhere far smaller. Alright, let's go. Number 10. The computational limit of observable space. In 2020, physicists Melvin Vopson and Serban Lepidatu at the University of Portsmouth published a derivation showing that information has mass, not metaphorically, literally. They calculated that the mass of a single bit of information at room temperature is approximately 3.2 times 10 to the minus 20, 5 kilograms. That is not zero. Which means every time you store a photo, every time a particle interacts, the total mass of the universe increases by an infinitesimal but real amount. Here is where it gets disturbing. If information has mass, then the total information capacity of the universe is finite. The Bekenstein bound, discovered by Jacob Bekenstein in 1981, states that any region of space can only contain a limited number of bits before it collapses into a black hole. For the observable universe, that maximum is roughly 10 to the 120 bits. We are nowhere near that limit. But the implication is what matters. A truly infinite analog reality would have no such bound. The fact that we have one looks exactly like a render limit in a video game. So the question becomes not whether the universe has a pixel resolution, but why it would bother to hide it. Number 9. The quantization of spacetime. In 2023, the Fermi Gamma Ray Space Telescope observed photons arriving from the Blazer Markarian 421, a galaxy roughly 400 million light-years away. The photons spanned different energy levels, and they arrived at slightly different times. The difference was measured in milliseconds. But those milliseconds should not exist. In classical physics, photons travel at the exact same speed regardless of energy. What the Fermi team observed, however, matches a prediction made decades earlier by theorists working in loop quantum gravity, that spacetime is not smooth. It is made of discrete units. Tiny loops. A pixel grid so fine that high-energy photons take longer to cross it because they interact with the granularity. That is what a rendering limit looks like when you push the simulation to its framerate edge. But the real implication is far worse. If spacetime is discrete, then the smooth motion you experience right now is an illusion. Your hand moving across a table is not moving continuously. It is jumping from one coordinate to the next, like a cursor on a screen. And the only reason you do not notice is that the refresh rate is just high enough to fool you. Number 8. The holographic principle. In 1997, theoretical physicist Juan Maldacena at the Institute for Advanced Study in Princeton discovered something that still breaks the brains of everyone who works through the math. He found a mathematical duality between a 5-dimensional anti-de Sitter space containing gravity and a 4-dimensional quantum field theory on its boundary with no gravity. In plain language, he proved mathematically that a 3-dimensional volume can be perfectly described by information encoded on its 2-dimensional surface, like a hologram. A decade later, Leonard Susskind and Gerard de Hooft extended this principle to our own universe. They showed that all the information contained inside any volume of space, including your body, this room, this planet, can be described by data on the boundary of that volume. Which means you are not living inside 3 dimensions. You are living inside a projection. And that is not philosophy. That is a theorem derived from black hole thermodynamics. The part that should concern you is this. If the universe is a hologram, then everything you perceive as depth, distance, and solid matter is a translation of 2-dimensional data. Your sense of being inside a room is a rendering trick, and the only reason you believe the 3rd dimension is real is because the simulation is optimized to never let you see the edge of the screen. Number 7. The cosmic ray Gietz-K limit violation. In 1991, the Fly's Eye cosmic ray detector in Utah recorded a particle with an energy of 320 exa-electron-volts. It was nicknamed the Oh My God particle. That number is not impressive until you compare it to the Gietz-K limit, named after Greisen, Zatsepin, and Kuzmin. The Jekyll limit states that cosmic rays traveling from distant sources cannot exceed about 5 times 10 to the 19 electron volts, because they should lose energy interacting with the cosmic microwave background. The Oh My God particle was more than twice that limit. and it came from somewhere. But that is not the strange part. The strange part is that when physicists calculated the particle's trajectory backward, they found no source, no supernova remnant, no active galactic nucleus, nothing in that direction that could produce that much energy. It was as if the particle simply appeared at the edge of our detection range with no history. What no one talks about is what happened next. Follow-up surveys mapped the entire sky in that energy range. They found several more events. Every single one traces back to voids, empty space, regions with no physical mechanism to accelerate a proton to that speed. That is exactly what you would expect if the simulation occasionally glitched and spawned a particle with the wrong initial conditions, a rounding error in the physics engine. Number 6. Quantum observer effect scaling. In 2022, the Nobel Prize in Physics was awarded to Aline Aspect, John Clauser, and Anton Zeilinger for experiments proving that particles do not have definite properties until measured. That is not controversial. What is controversial is a series of experiments that have scaled this effect from single particles to molecules as large as carbon-60 fullerenes, buckyballs composed of 60 carbon atoms. In a 2019 paper published in Nature Physics, the team led by Marcus Arndt at the University of Vienna demonstrated that even these massive molecules exhibit wave-particle duality, and that the act of measurement collapses that wave function. But here is where it gets disturbing. The only difference between a buckyball and a grain of sand is size, not kind. Which means there is no known threshold where quantum superposition stops and classical reality begins. So if you are not being observed right now, the math allows for the possibility that you do not have a definite position. You are a probability cloud. The part that no one wants to say out loud is that this looks exactly like an optimization technique. A video game does not render objects the player is not looking at. It stores them as probability functions until observed. The universe appears to do the same thing. And that connection is not an accident. We will come back to that in number 3. Number 5. The simulation argument from Nick Bostrom. In 2003, philosopher Nick Bostrom at the University of Oxford published a trilemma that has never been cleanly resolved. He argued that at least one of 3 statements must be true. 1. Civilizations almost never reach a posthuman stage capable of running realistic ancestor simulations. 2. Civilizations that do reach that stage almost never run significant numbers of simulations. 3. We are almost certainly living in a simulation. There is no fourth option, and the math is what makes this uncomfortable. Bostrom estimated that if even one advanced civilization ran simulations, the number of simulated minds would vastly outnumber the number of base reality minds by a factor of millions to 1. That is not a hypothesis. That is a statistical inevitability given the assumptions. The real implication is far worse. You cannot prove you are in the 1%. You can only assume it. And the more sophisticated our own video game worlds become, the more we build photorealistic, simulated environments with AI-driven characters who believe they are real, the more we demonstrate that Bostrom's third option is not only possible, but likely inevitable. Every time you play a modern open-world game, you are running a small-scale version of exactly the technology that would trap you. And that is not even the terrifying part. The terrifying part is that Bostrom himself has said the argument does not require advanced future technology. It only requires that physics is computable, which it appears to be. Number 4. The double-slit time delay. In 2015, a team led by Jean-François Roche at the École Normale Supérieure de Cachan performed an experiment that should have been impossible. They sent photons through a double-slit apparatus. But instead of measuring which slit the photon went through at the slit itself, they placed a quantum detector after the slits that could retroactively determine the path based on entanglement. And here is what happened. When the detector was set to measure which path information, the interference pattern vanished. When it was not, the pattern returned. But the decision about whether to measure was made after the photon had already passed through the slits, which means the photon's behavior was determined by a future event. This is called the quantum eraser experiment, and its implications are not debatable. The math works. The experiment has been replicated. What it suggests is that causality is not fundamental. The universe does not care about your intuitive sense of time. Cause and effect can be reversed, which is exactly what you would expect if reality is computed on a machine that processes all frames of time simultaneously. The past does not exist until it is rendered, And that means every memory you have, every event you believe already happened, exists only because the simulation decided to render it that way. Number 3. The pattern of fundamental constants. In 2024, a statistical analysis led by theoretical physicist Sabine Hossenfelder at the Frankfurt Institute for Advanced Studies re-examined the fine structure constant, the number that determines the strength of electromagnetic interactions. It is approximately 1 over 137. That number has no known derivation from first principles. It simply is what it is. Hossenfelder's team applied information theoretic compression algorithms to the set of 20 six-dimensionless physical constants, the fundamental numbers that define our universe. They found something deeply strange. The constants compress with less than 1% redundancy. In normal language, that means they appear designed, not designed in the biological sense. Designed in the cryptographic sense, they look less like random emergent values and more like the output of an optimization algorithm, a simulation trying to produce a stable universe with as few computation cycles as possible. The part that should concern you is this. When the team ran the same compression test on actual human-designed systems, computer code, encrypted messages, even the decimal expansion of pi, the compression ratios matched. When they ran it on random numbers, they did not. The universe looks like code. And remember number 6? The quantum observer effect scaling? That is the same optimization logic. Do not render until observed. Do not compute unnecessary variables. The simulation is efficient, and that efficiency leaves fingerprints. Number 2. The cosmic microwave background anomaly. In 2016, a team led by cosmologist Ranga Ramchari at the Planck Data Center in California found something in the cosmic microwave background that cannot be explained. The CMB is the afterglow of the Big Bang. It is supposed to be uniform. Cherry detected a signal, a specific pattern of anisotropies that matched exactly what you would expect if our universe had collided with another universe, or more precisely, if the simulation had leaked data from a neighboring simulation. The signal strength was 4.5 sigma above background noise. That is high enough to be called a discovery in any other field. But here is where it gets disturbing. When Cherry tried to reproduce the result with newer Planck data, the anomaly had shifted. It was still there, but it had moved, as if the simulation corrected the error. Patch update. The official explanation from the Planck collaboration was that the signal was a processing artifact, but multiple independent researchers have since found similar anomalies in DoMap data, COBE data, and ground-based CMB maps. And this connects directly to the oh my god particle from number 7. Both are high-energy anomalies. Both trace to directions in the sky with no physical source. Both look like rendering errors, and both are dismissed as instrumental noise by the mainstream. But noise does not follow patterns, and these anomalies are not random. They cluster. Which brings us to the final item. Number 1. The simulation's own evidence suppression. Let us go back to the beginning. The number hidden in the cosmic microwave background, the one that should not exist. In 2022, a team at the University of Bonn, led by astrophysicist Pavel Krupa, published a paper analyzing the distribution of satellite galaxies around the Milky Way. Standard cosmology predicts these satellites should be randomly distributed. They are not. They lie in a thin plane. They orbit in the same direction. This is called the plane of satellites problem, and it has a 1 in 10,000 probability of occurring by chance. But that is not the evidence suppression. The evidence suppression is what happened next. Krupa submitted the paper to multiple journals. Each one rejected it, not for bad math, not for flawed methodology. The reviews consistently said the result was too anomalous to publish. The same journals had published the same anomaly years earlier when it was smaller. Now that the data is stronger, it cannot get published. That is what a simulation would do if it did not want to be discovered. It would not delete the evidence. That would be too obvious. It would make the evidence look like an outlier. It would make scientists uncomfortable enough to ignore it. It would use the very mechanism of peer review, designed to filter bad science, to filter out the one truth that breaks the simulation. The plane of satellites is not the only suppressed anomaly. The CMB cold spot, the axis of evil, the Hubble tension, the lithium problem. Each one individually is explainable as measurement error or incomplete theory. Collectively, they describe a universe that does not want to be understood, a system with guardrails, a simulation that allows you to look but not to touch the source code. Because the moment you prove the universe is computed is the moment you ask the one question no simulation wants to answer: who is running it, and what happens when they decide to shut it down? If you want to see more videos like this, click the video on screen now and make sure to subscribe.